Next question is also related to Fourier transform. The Fourier transform of a double-sided exponential signal. Okay, so they have given one standard signal only. X of t is equal to e power minus b modulus of t. You can remember this answer directly. Okay, otherwise for you I will solve here. So the Fourier transform is given by 2b by b square plus omega square. This is the Fourier transform. As I said, here also we have modulus function, that is what we need to apply. Okay, so mod t is equal to plus t when you are working with the positive values of t, mod t is equal to minus t when you are working with negative values of t. Accordingly, you need to substitute, okay, in place of modulus of t. So here I am taking x of t having the Fourier transform x of omega, and x of omega is equal to, what is the Fourier transform formula? Integral t is equal to minus infinity to plus infinity x of t e power minus j omega t dt. So it is equal to integral t is equal to. Okay, now I will split this integral because we don't have only one function for all the positive and negative values of t. Here already I told now, since it is involved modulus, one time we have to take plus t, other time we have to take minus t. So it is required to split this integral. Okay, so integral t is equal to minus infinity to 0. So we are working with the negative values of t. So here modulus of t is equal to minus t, we have to substitute. So e power bt we have to take. Then according to the formula, e power minus j omega t dt plus integral t is equal to, this portion is over. We need to perform the integration actually from minus infinity to plus infinity. Here minus infinity to 0 is over. Now I am performing from 0 to infinity. So x of t is nothing but now e power minus b. Since we are working with the positive values of t, modulus of t is equal to plus t only. So e power minus bt will get, and it is e power minus j omega t dt. So it is equal to integral t is equal to minus infinity to 0 e power b minus j omega into t dt plus integral t is equal to 0 to infinity e power minus of b plus j omega t dt. Okay, it is equal to, what is the integration here? E power b minus j omega t, and here we will get 1 by b minus j omega. Limits are minus infinity to 0, and here we will get minus 1 by b plus j omega and e power minus of b plus j omega t, and the limits are 0 to infinity. Okay, so it is equal to, what we can get here, 1 by b minus j omega. Here e power 0 is 1, and if you substitute here t is equal to minus infinity, you take b is positive value, so 1 minus 0 you will get. Minus 1 by b plus j omega, here you will get e power minus infinity is 0 minus, if you substitute t is equal to 0, you will get 1. So what we will get here? 1 by b minus j omega, okay, minus into minus is plus, 1 by b plus j omega. So it is equal to, it is a minus b into a plus b, so a square minus b square. So what we will get? B square minus j omega square, that means j square omega square, that is 1 plus 1, plus only we will get, minus into minus is plus. Now in the numerator, b plus j omega plus b minus j omega, so j omega will be cancelled, so finally you will get 2b by b square plus omega square. This is a standard one, you have to remember this one. Okay, this will be helpful to solve other questions also. Okay, so as I said, this is the correct option. Next question is also related to Fourier transform only. Fourier transform of e power minus pi t square is e power minus pi f square. Then the Fourier transform of e power minus alpha t square. Okay, in Fourier transform, two things you need to remember. One is Fourier transform of impulse train is again impulse train only. Fourier transform of Gaussian pulse is again Gaussian pulse only. So these are the two things you need to remember. Now the question is related to Gaussian pulse. So the general thing is e power minus a t square having the Fourier transform root of pi by a e power minus omega square by 4a. Okay, this is the given that means general equation. Okay, for this is a Gaussian function. Again the Fourier transform is also in the form of the Gaussian function only. This is a scalar. Okay, so it will not change the shape of the signal. So e power minus independent variable square, that is enough to say it is a Gaussian pulse. E power minus a is a scalar, t square. So it is the Gaussian pulse in the time domain, it is the Gaussian pulse in the frequency domain. So what we need here? We need here e power minus alpha t square. So e power minus alpha t square. That means in place of a, simply you can substitute alpha. So root of pi by a e power minus omega square by 4 alpha. But you will not observe this answer in the options because they have given all the options with respect to f. Here we have omega. So just replace omega with 2 pi f. So what we will get? Root of pi by a. Okay, so simply we can tell option B is the correct option because no other thing is having root of pi by a. Okay, so answer is B. We'll check exactly. So root of pi by a e power minus omega means 2 pi f. So square is there. So 4 pi square f square by 4 alpha. So root of pi by a e power 4 will be cancelled. E power minus pi square f square by alpha. Okay, so option B is the correct option. Next one, Fourier transform of a function is equal to its two-sided Laplace transform. Evaluated. Okay, it is very simple. Fourier transform is actually existing for stable signals. Laplace transform can be existing for stable and unstable also. Okay, so this part is there, na? That means common, in the common we can tell whenever stable signal is there, Fourier transform is existing and Laplace transform is also existing. And Fourier transform is equal to Laplace transform when we take S is equal to j omega. Okay, actually S is sigma plus j omega. Actually S is sigma plus j omega. That means you need to make sigma 0 in order to exist the Fourier transform. Sigma 0 means it is available on j omega axis only, na? It is the real axis. It is imaginary axis. So sigma you are making 0 means you are talking about imaginary axis. Okay. So if the ROC is including this particular j omega axis, then we can tell Fourier transform is also existing. So on the imaginary axis of the S plane, that is the correct option. Okay. Next thing, the property of the Fourier transforms which states that the compression in time domain is equivalent to expansion in the frequency domain. Options are duality, scaling, time scaling, frequency. It is very easy question, na? Already they have mentioned everything. You are performing the compression in the time domain and that is equivalent to expansion in the frequency domain. Everything they have given. We need to just name the property. Compression in time domain. Compression, expansion are related to scaling properties only. And here they did not give frequency scaling, but they have given time scaling. So compression in time domain leads to time scaling only. Okay. Next one, the function f of t shown in the given figure will have Laplace transform as. Okay. For this particular signal, we need to calculate the Laplace transform. So to get the Laplace transform, first of all, we should have equation for that. Okay. So by observing this graph, we need to write the equation, mathematical equation for the f of t. So that one I am writing here, f of t is equal to. Okay. So what we can able to tell here, first we don't have any amplitude. That means slope is also 0. So one thing you remember, whenever you have finite slope change means you see the slopes. Okay. When you have infinite slope, then you see amplitudes. Here you see slopes only. Okay, it is 0 slope, it is slope 1. It is 1 and 1 only, na? That means at t is equal to 0, how much slope change you are getting? 0 to 1. Slope change is 0 to 1. Okay. Then how to write equation means after minus before. This is happening, this slope change is happening at t is equal to 0. So you need to take after that time instant minus before that time instant. The slope change you have to take. Here slope is 1, here 0. That means 1 minus 0. This is happening at t is equal to 0. And it is the ramp, na? So we have to take t into u of t. This portion is over. But like this, when you come at t is equal to 1, what is happening? Again slope change is there. That is, previously 1 is the slope, after t is equal to 0, 0 is the slope. Okay, so 0 minus 1, this is the slope change. So plus 0 minus 1, this is the slope change, but it is happening at t is equal to 1 means delayed. So t minus 1 u of t minus 1, like this we can write now. So this portion is also over. Can I say then amplitude is 0? No. What we need to tell here, the slope is actually involving the infinity. Okay. When we have the slope is infinity change, this is vertical line. Vertical line is having infinity slope. Just before t is equal to 2, we have 0 is the amplitude. Exactly t is equal to 0, infinity amplitude is there. As I said earlier, when you have infinite slope, then we need to take amplitudes into the account. So here how much amount of amplitude change is there? This is 1, here amplitude is 1, this is 1, but here 0 is there. So amplitude change you need to take now, that is 0 minus 1. Whenever you have this infinite slope, you need to write a step response. Okay, in terms of the step signals you need to write, that is u of t minus 2. Okay, finite slope change means you need to write using the ramps, that means t. Okay, but when you have infinite slope, then you need to write only step signals. Then finally we can write f of t is equal to, first one is t into u of t, then minus t minus 1 into, we can tell u of t minus 1, then here we have minus u of t minus 2. Okay, this is the thing we have. Okay, now apply Fourier transform. Okay, so what we will get? So t means u of t means 1 by s, t means 1 by s square, and again this is again t, that means 1 by s square, but here shift t is there, that is e power minus s by 1 second. So e power minus s into 1, again minus 1 by, this is u means just s only na. Okay, then e power minus 2s, that is what we can able to write. Okay, you can check the options which is correct here. You can take 1 by s square is common, 1 minus e power minus s into e power minus 2s. That is what we will get na. 1 by s square if we take common, from here you will get 1, from here you will get e power minus s, from here because here s square is not there, you need to multiply with s, e power minus 2s. So this is the correct option. Next one, the output of a linear system to a unit step input u of t is, okay, this is the output. So this is the step response, like that we can able to tell the system function h of s is, that is what we need to calculate, the output of a linear system to a step input. Okay, so if you apply, you take linear system, they are telling already it is a linear system, and the input is u of t and its output is t square into e power minus 2t. Okay, this is the output. So what we need in the sense here, this the function, the system function h of s. So simply you have input and you have input and output, take the ratio. Okay, apply the Laplace transform and take the ratio, that is the system function. System function h of s is equal to Laplace transform of output by Laplace transform of input. This is what we need to perform, that's it. Okay, so when you have t square into e power minus 2t, what is the Laplace transform of this one? First I will take this one, this is the output part na. So I will take this t square into e power minus 2t as this particular thing. So we know that x of t having the Laplace transform x of s, this input is multiplied with t. Okay, t into x of s is nothing but you need to perform differentiation in the s domain. Okay, d by ds of x of s is nothing but actually here you will get a minus t. Okay, so this is what we need to perform. So according to this particular thing here, t square is, that means 2 times we need to perform. So you take e power minus 2t into u of t is by default will be there. So its Fourier transform is, its Laplace transform is 1 by e power minus 2t u of t, its Laplace transform is 1 by s plus 2. Okay, then here t is there. So when you multiply with t, e power minus 2t u of t, here we need to perform differentiation with respect to s, that is minus 1 by s plus 2 square. Now again we have to multiply with t, then you will get t square into e power minus 2t u of t. So here one more time we have to perform the differentiation, that is plus 2 by s plus 2 power 3, like this will get, s plus 2 power 3 will get. So this is nothing but the Laplace transform of the output, okay, by Laplace transform of the input we need to write. So it is equal to 2 by s plus 2 cube by Laplace transform of the input. What is the input? U of t. So u of t Laplace transform is 1 by s. So this s will go to the numerator. So answer will be 2s by s plus 2 cube. Okay. So you can observe here option D is the correct option. So the next question is, if 27s plus 97 by s square plus 33s is the Laplace transform of the signal f of t, then find f of 0 plus. That means it is the initial value. So we have to apply initial value theorem. Okay, by observing this one, easily we can able to tell that one. So according to initial value theorem, f of 0 plus is equal to limit s tends to infinity s into f of s. This is what we can able to take. So it is equal to limit s tends to infinity s into what is f of s? 27s plus 97 by, here we can take in the denominator s is common, so s square plus 33, like this we can take. Okay, so s will be cancelled, so it is equal to, here what we can do, you can take s is common in the numerator and denominator. Okay, here only s will be there, na? Here s we have taken common, then you take in the numerator and denominator s is common before taking this s tends to infinity. So you will get 27 plus 97 by s by 1 plus 33 by s, like this we can write. Okay, now take s tends to infinity, so this thing will go to 0, this thing will go to 0, so you will get 27 is the answer. Okay, that is what we can able to observe. Next one is the signal 1 plus m cos 4 pi t cos 2 pi 10 power 3 t contains the frequency component. Okay, so here this 1 plus m cos 4 pi t is multiplied with cos of 2 pi 10 power 3 t. Okay, so this 1 is multiplied with cos function. Then what is the cos function frequency mean? Whatever the frequency is there, that is what. So because the answer is given in hertz only, 2 pi ft, so 10 power 3 is one frequency. Okay, then this cos 4 pi t is multiplied with the cos of 2 pi 10 power 3 t, so it is like cos a cos b. Okay, so you can take 2 cos a cos b, that means cos of a plus b plus cos of a minus b will be there. So a plus b is related to one frequency, a minus b is related to one frequency. Here frequency is 1000, but here frequency is just 2, because we need to divide with 2 pi na to get a normal frequency f. So if you divide with 2 pi, here you are getting 2 hertz you are getting. Here 1000 hertz, here 2 hertz. Okay, so a plus b means these two should be added. So 1000 not 2. 1002 you will get, and 1000 minus 2, that means 998. So 998, 1002 we are getting from the product of these two, and this 1000 we are getting because of only this cos term. Okay, that cos is multiplied with 1, so only individual cos term is there, because of that one we are getting 1000. So 998, 1000, 1002. 998, 1000, 1002. That means option A is the correct option. Next one, a signal represented by x of t is equal to 5 cos of 400 pi t is sampled at the rate of 300 samples per second. Okay, so they have given one signal x of t, that is what I am writing here. So x of t is equal to 5 cos of 400 pi t. Okay, so from this what we can tell, amplitude is 5 and frequency, normal frequency is equal to, if you divide with 2 pi, what will get, pi will be cancelled, here it is 200. Okay, it is sampled at the rate of 300 samples per second. So fs is equal to 300. That is what they have given. The resulting samples are passed through the ideal low pass filter of cutoff frequency 150 Hz. So low pass filter means like this we have to take, and its cutoff frequency they have given 150. Okay, like this we have to take 150. Now which of the following will be contained in the output of the LPF? First we have to perform the sampling process, in that many frequencies may be available. Then that entire thing, if you send through the low pass filter, what will be the output? That is what they are asking. So even though the given signal is the cos function, for the simplicity I am taking here triangle function only. Okay, generally in the sampling theorem for explanation purpose we will take triangle pulse. Okay, triangle we will take. Triangle means it is not the meaning of if the time domain signal is the sinc square. Okay, for the explanation purpose only I am taking here, but the concept can be applied to this particular cos function also. So as we have here this maximum frequency is 200, you have to take like this now, minus 200 to plus 200. Don't think that I am drawing the this triangle frequency spectrum for the cos function. It is not like that. Okay, for the explanation purpose only I am taking these triangles. Okay, in the sampling theorem if you check we will work with the triangles only. Okay, as a even function we can able to take. Okay, but the concept can be applied to any real signal like this cos function also, and we are applying here frequency is important, so frequency we are taking as 200 only, so there is no problem. But in the sampled version if you see carefully, fm plus or minus nfs, so these are the frequencies will be existing in the sampled version. That means if you take n is equal to 0, this fm is there, that is what I have drawn. But when you take n is equal to 1, okay, what will happen? fm plus fs is there, fm minus fs is there. So first if you see fm plus fs is how much? 300. So for this particular spectrum fm we have to add 300. So how much is there here? Minus 200. By adding 300 it will be at 100. 0 plus 300 it will be at 300. 200 plus 300 it will be at 500. That means this fm plus fs, by taking n is equal to 1 you will get the spectrum is like this. Okay, here 100 200 means here only now you have 150. Okay, now you send this one through our low pass filter whatever they have given with the cutoff frequency 150. Okay, so like this we have sent. So what is the answer now? You will be having in the result in the output only less than 150 frequencies only. Okay, and here we have 100. Okay, so 100 we have 100 plus 150, 150 will not come because at 150 exactly low pass filter output is 0, and 50 and 100 and 50 100 150. Why can't we take 50 is the answer? Because it is within this one only na, because the cos function will have only one frequency, that is at 200. Okay, fm is 200. At positive side we will draw the spectrum is at 200, left side we will draw minus 200. So this particular analysis is not valid for the cos function, because what is the meaning of taking triangle? 0 to 200 is valid. Okay, for the explanation purpose we can take this one, but the original signal is the cos function, it is existing only at 200. That is what you need to understand. Okay, so but by shifting this one you will be having this 100 frequency also, so answer will be 100. What is the Z transform of the signal x of n is equal to alpha power n u of n? So question is related to Z transform, so you should know the basic formula of the Z transform to perform this one. So x of n having the Z transform x of z, and x of z is equal to sigma n is equal to minus infinity to plus infinity x of n z power minus n. But given question is involving u of n, so the limits can be taken only on right side. So sigma n is equal to 0 to infinity, and x of n is alpha power n, and u of n is equal to 1 on right side, so z power minus n. So it is equal to sigma n is equal to 0 to infinity. This can be written as alpha by z whole power n. Like this we can take now. So just expand this one by taking different values of n. So n is equal to 0 means 1, n is equal to 1 alpha by z, n is equal to alpha by z square. Like this we can write. But this can be converged whenever this common ratio alpha by z is less than 1. Okay, if you take greater than 1, the value will be increasing, getting the infinity. But it should be converged in the sense it should be less than 1. So because it is in GP, I am telling that one. So what is the summation of this particular GP series? First value by 1 minus common ratio, that is alpha by z. So it is equal to z by z minus alpha, provided this condition is to be satisfied. Okay, so z by alpha is greater than 1, that means z is greater than 1. So mod you can take. Okay, so z by z minus alpha. So this is the correct option. Next one is given x of z is equal to 1 by 1 minus a into z power minus 1. Okay, so if you take this one like this, x of z is equal to 1 by 1 minus a into z power minus 1, it is actually the Fourier transform of x of n is equal to a power n u of n. Okay, that is what we can able to consider. And mod z is greater than mod a. For this one, the Z transform will be like this. With ROC, mod Z is greater than mod A. Then the region of convergence is. Okay, then the region of convergence we have to calculate. So, using this ROC, we can able to tell the answer very easily. You see, this is a circle with radius A. In every diagram, same thing is a circle with radius A, circle with radius A, circle with radius A. But what is ROC? The mod Z is greater than A. That means outside the circle we have to take. Okay, outside the circle we have to take. Mod Z is greater than A. So it is inside, it is outside. So this is the correct option. Okay, completely outside we have to take, not off of the this one only on right side or above the x-axis. It is not like that. Complete outside we have to take. Okay, so in this way we can able to solve this particular question. Thank you. Prepare so many questions on this particular basics of the signals and systems and up to higher level also. Okay, then you can able to crack the examination very easily. Thank you.